Okay, so this is the chapter on questions and answers on chemical calculations. So let us take a look at the answers to the questions that you should have tried. Please make sure that you try all the questions before you go through this video, because if you do not try it on your own, you will not understand what's going on. So first try the questions as much as you can, go back to the notes and try as much as you can, and then take a look at the answers. So the first question that you have there says N2O4 is a poisonous gas. It can be disposed of safely by reaction with sodium hydroxide, and he gives you a certain equation. Now, what is the minimum volume of 0.5 mole per decimeter cubed sodium hydroxide needed to dispose of, or needed to react with, 0.02 mole of N2O4? So he says the number of moles of N2O4 is 0.02. So, and he's asking me about sodium hydroxide, so the first thing I should do is relate the number of moles, and then I can get the volume. So, if I have 0.02 mole, the equation tells me that 1 mole of N2O4 will react with 2. That means that the number of moles of sodium hydroxide should be twice the number of moles of N2O4. So, if I have 0.02 mole of N2O4, the number of moles of sodium hydroxide should be 0.04. And that means that the volume, how do I get volume of a solution? Remember, number of moles over concentration. So the number of moles is 0.04, the concentration is 0.5 as he says in the question, and that means that I have 0.08 decimeter cubed. Remember that what comes out of this equation is in decimeter cubed. Now the choices are in centimeter cubed, so I have to multiply by 1,000. So my answer is D. Okay, what mass of solid residue can be obtained from the thermal decomposition of 4.1 gram of anhydrous calcium nitrate? And this is the equation that you should have. Okay, so he says I'm starting with 4.1 grams of calcium nitrate. Remember that we do not relate grams directly. So I cannot say the equation says okay. First of all, he wants mass of solid residue. Now, what is coming out from this reaction? Calcium oxide is the solid, but nitrogen dioxide and oxygen are gases, so I'm not going to talk about that here. So, from the equation says 2 moles of calcium nitrate should give 2 moles of calcium oxide. That means that the number of moles of calcium oxide is the same as the number of moles of calcium nitrate. Number of moles, not mass. I cannot calculate mass, I cannot relate mass and say, okay, 2 gives 2, then 4.1 will give how much? I cannot say that. I have to change the 4.1 to number of moles first, and then relate the number of moles. So number of moles of calcium nitrate, what does he give me? He gives me mass, so I need to use the equation that involves mass. Mass over molecular mass. So number of moles of calcium nitrate is number of moles is mass over molecular mass. If you calculate the molecular mass of calcium nitrate, it's 164. Do you understand how to calculate molecular mass now? You have 1 calcium, its mass is 40, plus 2 nitrogens, each of them is 14, plus 6 oxygens, and each of them is 16. So the molecular mass of calcium nitrate is 164. Then the number of moles is the mass that he gives me, 4.1 over the 164. So that means that I have 0.025 mole. And we've decided from the equation that the number of moles of calcium oxide is the same as that of calcium nitrate. So it is 0.025. Now, what is he asking? He's asking for mass. How do I get mass? Mass is number of moles times MR. MR of the calcium oxide we're talking about. So that means that I end up with 1.4 grams, which is C. Okay. In leaded petrol, there is an additive composed of lead, carbon, and hydrogen. Only this compound contains this percentage of carbon and this percentage of hydrogen. He didn't mention lead, so I have to get lead. How do I get lead? If this is percentages, then the lead is the rest of the 100. So you add them and subtract from 100, so I end up with 64.11% of lead. Now, basically we're trying to get empirical formula. And you said, how do we get empirical formula? Write the symbols of each one, the percentages of each one, and then we go through 2 steps. What was the first step? Divide by atomic mass. So if I divide this by atomic mass, which is the big number from the periodic table, I get these numbers. Okay, and then what was the next step? We said we look at these numbers and divide by the smallest. So 0.31 was the smallest, so I divide through by 0.31. I get the ratios are 1 to 8 to 20. That means the X that he has in that formula is 20. Okay, now this is a similar reaction to the other one, magnesium nitrate to give magnesium oxide, nitrogen dioxide, and oxygen. And he says magnesium nitrate will decompose when heated to give a white solid. So which of these is the white solid? It's the magnesium oxide. And a mixture of gases, we said NO2 and O2 are gases. Now one of the gases released is an oxide of nitrogen, so he's talking about the NO2. Now 7.4 grams of anhydrous magnesium nitrate is heated. What mass of NO2 is produced? Again, if he gives me mass of something, the first thing I need to do is get the number of moles. This is from mass, so number of moles is mass over molecular mass. I calculate the molecular mass of magnesium nitrate, and then I divide the mass over the molecular mass, and we find that the number of moles is 0.05. The next step would be, what is he asking about? He's asking about NO2. So what is the relationship from the equation between magnesium nitrate and NO2? The equation says if the number of moles of magnesium nitrate is 2, the number of moles of NO2 is 4. So 2 gives 4. So the 0.05 will give how much? So the NO2 is basically twice of the magnesium nitrate, so it will give 0.1 mole. Now I know the number of moles of the NO2. What is he asking about? He's asking about mass. How do I get mass? Mass is number of moles times mR. So the number of moles of the NO2 times the mR of the NO2, and that comes out to be 4.6 grams. Okay, were you able to get this? I really would like to know if you were able to do it. Okay, this is a similar reaction but with calcium nitrate. What volume of oxygen? Where is oxygen in the equation? There. And from the equation says if I have 2 moles of calcium nitrate, I get 1 mole of oxygen. So what volume of oxygen measured under room temperature can be obtained from the thermal decomposition of 8.2 grams? So I'm starting with 8.2 grams of calcium nitrate, and he was kind enough to give me already the molecular mass of the calcium nitrate, so I don't need to sit down and calculate it. So the first thing that we need to do is number of moles. We know that he wants the volume, but the volume is related to the number of moles, so I need to get the number of moles. Okay, number of moles of calcium nitrate. Now what does he give me about calcium nitrate? He gives mass, so I need to use mass over molecular mass, so the number of moles is 0.05. Then I look at the equation. What is the number of moles of oxygen with respect to calcium nitrate? It is half of it, right? 2 gives 1, so that's half of it, so it is the number of moles of oxygen is 0.025, and the volume of oxygen will be the number of moles times 24, which is 0.6 decimeter cubed. But if he gives me the choices in centimeter cubed, that means I need to do what? I need to multiply by 1,000, so that means that my answer is the 600 centimeter cubed. Okay. Which sodium compound contains 74.2% by mass of sodium? Okay, how do we get percent by mass of something? If I have a compound like sodium carbonate and I calculate the molecular mass of sodium carbonate, then the percent of sodium will be the part of the sodium over the total times 100. So let's take a look at this. Sodium carbonate, the molecular mass, total molecular mass of sodium carbonate is 106. So the percent sodium is the part of the sodium, and remember that in sodium carbonate I have 2 sodiums. So 2 times 23 over the total times 100, that is the percent sodium. And we do the same for the others. Sodium chloride, this is the formula of sodium chloride, molecular mass of sodium chloride. So the percent of sodium is the part of the sodium, and here we have only 1 sodium, so 23 over the total times 100. Sodium hydroxide, I get the molecular mass, and I have only 1 sodium over the total times 100. Sodium oxide, I get the molecular mass, and the percent of sodium is 2 times 23 over the total times 100, and this is the one that has 74.2% by mass sodium. Okay. what is the concentration of a solution containing 1 gram of sodium hydroxide in 250 centimeter cubed of solution? Okay, he wants concentration, and I know that concentration is number of moles over volume. So I need to get the number of moles first before I can get concentration. Now, what is he telling me about sodium hydroxide? He's giving it in mass, 1 gram. So I need number of moles is mass over molecular mass. The mass is 1 over the molecular mass of sodium hydroxide, and that comes out to be 0.025 mole. So I have 0.025 mole. He wants concentration. Concentration is number of moles over volume. Remember, the volume that is put into the equation has to be in decimeter cubed. He gives me the volume in centimeter cubed. I have to divide by 1000 before I put it into the equation. So that comes out to this concentration, which is B. Okay. Copper 2 carbonate is broken down by heating to form copper oxide and carbon dioxide. The equation for the reaction is shown. 31 grams of copper carbonate are heated until all the contents of the test tube have turned from green to black. That means it has completely reacted. And the yield of copper oxide is this. So just let's ignore the mass of copper oxide for now, because this is just the actual yield that he got in the experiment. But what did he start with? He started with 31 grams of copper carbonate, and he wants what is the percent yield. So in order to get the percent yield, I have to calculate how much he should have gotten. So if he starts with 31 grams of copper carbonate, I get the number of moles of copper carbonate, mass over molecular mass. The molecular mass of copper carbonate is this. That means number of moles would be 0.25 mole. Okay. So now I have the number of moles of copper carbonate, but he's asking about copper oxide, and I see from the equation that the equation says 1 gives 1, and that means that the number of moles of the copper oxide is the same as that of copper carbonate. Okay, then we can get the mass, the actual, the theoretical mass that he should get. So mass is number of moles times mR. We do that and we get that he was supposed to get 20 grams. But what did he actually get? He got, the word yield means the actual mass, the mass that he got. The mass that he got is 17.5, so the percent yield is what he actually got over what he should have gotten, which is the theoretical that we calculate, times 100. Okay, so my answer is D. Okay. Sodium carbonate solution reacts with the acid, and he gives me the equation, and he's saying he put excess sodium carbonate added to 10 centimeter cubed of 0.1 mole per decimeter cubed of hydrochloric acid. Again, I'm going to remind you, anything in centimeter cubed is volume, and anything in mole per decimeter cubed is concentration. So which volume of carbon dioxide gas is made? Okay. So I'm starting with HCl, and he's asking me about carbon dioxide. So I need to get the number of moles of HCl first, relate it to the carbon dioxide, and then get the volume of carbon dioxide. Okay, so how do we get the number of moles of HCl? We get the number of moles of HCl by putting concentration times volume. This is a solution, so the number of moles is concentration times volume. Again, I'm going to remind you that the volume of a solution has to be in decimeter cubed in order to put it into the equation. So that means that I have 0.001 mole of HCl, or 1 times 10 to the minus 3 if that comes out in your calculator. Okay, so that's the number of moles of HCl. Now I need to relate it to what? To carbon dioxide. Looking at the equation, the number of moles of carbon dioxide is what with respect to the HCl? It's half of it. So the number of moles of carbon dioxide is half of that, so that is the same as 5 times 10 to the minus 4. Then I get the volume of carbon dioxide. Volume of carbon dioxide is number of moles times 24. Number of moles that I get times 24 will give me an answer in decimeter cubed. The choices are in centimeter cubed, so I multiply by 1000 in order to choose the answer. Are we okay? Okay. The equation shows the complete combustion of propane. Which statement is correct? So let us take a look at these statements one by one. These are centimeter cubed of, remember that all of these are gases except for water. Now, we said we can relate directly the volumes of gases. So, the equation tells me 1 reacts with 5 to give 3 of CO2. This can be 1 mole reacts with 5 moles to give 3 moles, or 1 decimeter cubed or centimeter cubed or whatever reacts with 5 centimeter cubed to give 3 centimeter cubed. Do we understand that? Okay. We said we do not do that if we're talking about grams. I cannot say 1 gram reacts with 5 grams to give 3 grams. No, we don't do that. It is either number of moles or volumes of gases. Okay, so let's take a look at A. A says 10 centimeter cubed of propane cannot burn if less than 50 centimeter cubed of oxygen is present. That's really not true, because if I have 10 centimeter cubed of propane, okay, to allow all of it to burn, I need 50 centimeter cubed of oxygen. But if I have less oxygen, I can still burn some of it. So some of it will burn. Not that I don't have 50 then it will not burn. No. If I don't have 50 of oxygen, I have less than that, then some of the propane will burn. So A is wrong. Now, A says 10 centimeter cubed of propane would produce 40 centimeter cubed of liquid water. No. We cannot relate volumes if we're talking about liquids. We relate volumes only with respect to gases. Okay, C says 100 centimeter cubed of oxygen would be sufficient to react completely with 20 centimeter cubed of propane. If I have 20 of propane, how much do I need for oxygen? Yes. The equation says that the number of moles or the volume of the gas is 5 times that of propane. So if I have 20 of propane, 5 times of that is oxygen, so C is actually correct. If you look at D, this reaction would result in an increase in the volume of gases. No, that would not be correct, because the volumes of gases are not increasing, they're decreasing actually. Okay, now this one gives a reaction between sodium hydroxide and sulfuric acid, and he says which volume of this concentration of sodium hydroxide reacts with 50 centimeter cubed of 0.1 mole per decimeter cubed of sulfuric acid. So he gives me information about sulfuric acid and he's asking about sodium hydroxide. Okay, now in order to relate them, I cannot relate volumes because these are not gases, these are solutions. So I cannot say the volume of this reacts with the volume of this. So I have to change everything to number of moles. So I should get first the number of moles of the sulfuric acid, relate it to the sodium hydroxide, and then find what he's asking for. So how do I get number of moles of sulfuric acid? This is a solution. He gives me volume and concentration. So I use the equation that said concentration times volume. The concentration is 0.1. Remember, the volume has to be divided by 1000 if it is centimeter cubed. So this is 5 times 10 to the minus 3 mole. Now, that I look at the equation and I try to relate the number of moles of sodium hydroxide to the number of moles of sulfuric acid. The equation says that the number of moles of sodium hydroxide should be twice that of sulfuric acid. So if I have this number of moles of sulfuric acid, then the number of moles of sodium hydroxide would be twice of that. Okay? Remember that your answer, you can write it in standard form, 5 times 10 to the minus 3, or normal decimals, 0.005. Okay, so that means the number of moles of sodium hydroxide is 0.01. Now, what is he asking for? He's asking for the volume of the solution. How do we get volume of a solution? Volume is number of moles over concentration, because we said number of moles is concentration times volume, so that means that volume is number of moles over concentration. We already got that the number of moles is 0.01, and he says that the concentration is 0.4. So I get an answer in decimeter cubed, multiplied by 1000, I get the answer in centimeter cubed. Do we understand that? Okay, equation shows the thermal decomposition of magnesium carbonate. So magnesium carbonate gives magnesium oxide plus CO2. Which mass of magnesium oxide is formed when 21 grams of magnesium carbonate are completely decomposed? Again, I cannot relate grams directly. I need to change it to number of moles. So if he says I have 21 grams of magnesium carbonate, The number of moles is mass over molecular mass. Notice that sometimes he gives you a value for the molecular mass, so you don't need to sit down and calculate the molecular mass. If he doesn't give it to you, fine, but if he gives it to you, please use it. So before you sit down and calculate, check, did he give me the MR or not, so that you don't waste time doing the molecular mass. So here he says the molecular mass is 84. You divide the mass over the molecular mass, you get 0.25 mole of magnesium carbonate. Now, what is he asking about? He's asking about magnesium oxide. So I look at the equation and try to relate the number of moles. What is the number of moles of magnesium oxide compared to the magnesium carbonate? They are the same. So if number of moles of magnesium carbonate is this, then it is the same as the number of moles of magnesium oxide. And that means that to get the mass, the number of moles times the MR of magnesium oxide comes out to be 10 grams. Okay. A compound is analyzed and found to contain this of carbon and this of hydrogen. What is its empirical formula? Again, you sit down and calculate it. How do we calculate empirical formula? We said 85.7% carbon, 14.3% hydrogen. What was the first step that we should do? Divide by atomic mass of each one. So carbon is 12 and hydrogen is 1. I end up with these two numbers. Now, what is the next step? Divide by the smallest. And that comes out to be 1 to 2. So that is my empirical formula. Okay. An oxide of nitrogen has the following composition by mass. It has a relative molecular mass of 92. Remember that for all of these questions that we have been doing, we got only the empirical formula. But what if he gives me a relative molecular mass? Then he is asking for the molecular formula. So what we do is we go through the same steps to get the empirical formula. So the empirical formula is NO2. Now, in order to get the molecular formula, I calculate the molecular mass of the formula that I got. What is the molecular mass of the NO2? It's 46. But in the question, he's saying the molecule should not be 46. It should be 92. So I see 92 has how many 46 in it? So 92 is twice of 46. And that means that my actual molecular formula is twice of that. Do we understand what we did? So the empirical formula that you get, determine its molecular mass, compare it to the molecular mass that he says it should be, and it will be either the same or twice or 3 times or whatever. Okay? So my answer is D. Okay, so define, definition. Please memorize definitions. They're the easiest thing that you can get, easiest questions that you can get. So what was the definition of mole? Mole was relative atomic mass in grams. Which one was the Avogadro constant? We said an Avogadro constant is the 6.02 times 10 to the 23. So the Avogadro's law says 1 mole of a substance has 6.02 times 10 to 23 molecules. Okay, this question says 4.8 grams of calcium is added to 3.6 grams of water. What would be the number of moles of each one? So the number of moles of calcium from its mass is 0.12. The number of moles of water from the mass that he gives me, I'm not looking at the equation here. I'm using the information he's using, or the information he gives me, so I have 0.2 mole. Now, I need to decide which reagent is excess. Remember, we said if he gives me information about both reactants, I need to decide which one is excess. So in this case, I look at the equation and I find that the number of moles of water should be twice that of calcium, right? The equation says 1 calcium reacts with 2 water. So the number of moles of water should be twice that of calcium. Now, is it twice that of calcium? No, it's less than twice. That means that the water is limiting and the other one is the one that is excess. If you want to do it the other way around, you can say, okay, if the number of moles of water is 0.2, what should the calcium be? The calcium should be half of that, so it should be 0.1. He added more than 0.1, so the calcium is excess because only 0.1 mole is needed to react with 0.2 mole of water. In that case, once I decide that something is excess, that means I don't use its information. That means that if he's asking me about anything else in the equation, I use the number of moles of water, not calcium. And that's why we call water the limiting reagent. Okay, calculate the mass of the reagent named in 2, which remained at the end of the experiment. So if I need only 0.1 and he put 0.12, what is the mass that is left over? 0.1 and 0.12, the difference is 0.02 mole. So the excess number of moles is 0.02, and that means the excess mass is that number of moles times the MR, and that means he put an extra 0.8 grams of calcium. Okay, explain the phrase molecular formula. It is the formula showing the actual ratios between the atoms. This is the next question. A sample of rust had the following composition. Calculate the following and then write the formula of the sample of rust. Okay, remember that when we have masses, we deal with it as if it is grams. So the first step in getting empirical formula was dividing by atomic mass. So actually we're getting number of moles. So anyway, here number of moles of iron would be, how do I get number of moles? Mass over molecular mass. So that comes out to be this number of moles. Number of moles of oxygen, mass over the, this is oxygen atoms, so we're dividing by the atomic mass. And number of moles of water, I divide by the molecular mass of water. So I get these ratios of moles. Now we said if I want the simplest ratio, what should I do? I should divide by the smallest. If I divide by the smallest, I get 1 to 1.5 to 1. Remember that we said I cannot have fractions in my empirical formula or in my molecular formula. So what happens is, if one of them is 1.5, I need to multiply through by something. So 1.5, if I multiply through by 2, it will be a whole number. So I multiply everything by 2. So that means instead of 1 to 1.5 to 1, my ratio is actually 2 to 3 to 2. And that means that my formula is this. Remember that this is how we write the formula of a hydrated salt. Fe2O3, and then I have 2 water, so we put dot 2 H2O. Okay. Butanol reacts with ethanoic acid to form a liquid X, which has the sweet smell of bananas. Its empirical formula is this, and its molecular mass is this. So what would be the molecular formula? We said if I get the empirical formula, so he already calculated the empirical formula and he found that it is C3H6O. Now he's telling me that the actual molecular mass is 116. So the first thing I do is calculate the molecular mass of what he got, of the molecular mass of the empirical formula. Molecular mass of the empirical formula is 58. He's telling me it shouldn't be 58. It should be 116. Now 116 is how much of one of the 58? It is twice. So that means that my actual formula is twice of what he got. So instead of C3H6O, it is C6H12O2. Following? Okay. The next question says the equation for the complete combustion of butane is given below. Insert the 2 missing volumes. Remember, we said we can relate directly using the equation if we have volume of gases. So he says that the volume of CO2 is 40 centimeter cubed. Now from the equation says 2 of C4H10 gives 8 of CO2. So how much will give 40? That comes out to be 10. Oxygen also. Oxygen, the equation says 13 of oxygen will give 8 of CO2. So how much will give 40? 65. Direct relationship, cross multiplication. Okay. A hydride of arsenic has this composition. Calculate the empirical formula of this hydride from the above data. So he says arsenic is 97.4, hydrogen is 2.6, and we're trying to get empirical formula. The first step is divide by atomic mass. The numbers I get, I divide by the smallest. This gives me a ratio of 1 to 2, and that means that my empirical formula is ASH2. Don't forget to write the actual empirical formula. Don't stop at the ratios. And then he's saying the mass of 1 mole of this compound is 154 grams. What is the molecular formula? Okay, he's saying that the mass of 1 mole, remember that mass of 1 mole means molecular mass. He's saying the molecular mass should be 154. So I calculate the molecular mass of the empirical that I got. It comes out to be 77. Now the 154 has how many 77s? It's twice of 77, and that means that my actual molecular formula is twice the empirical. Okay, concentration of hydrochloric acid was this. The volume of acid needed to neutralize 25 centimeter cubed of lithium hydroxide was this. Do you understand what's going on here? Because most students get confused. He's giving me the concentration of hydrochloric acid. That's 2.2. Now, what is the volume of hydrochloric acid? The volume of acid needed to neutralize the lithium hydroxide was 20. So the 20 is the volume of the acid. Now calculate the concentration of the lithium hydroxide. So for the acid, I have concentration and volume, so I get the number of moles. Number of moles is concentration times volume. Again, volume has to be divided by 1,000, so I get this number of moles. Okay, so from the equation, I need to relate the number of moles of lithium hydroxide. So what would be the number of moles of lithium hydroxide? Well, the equation says 1 to 1. So if I have a certain number of moles of HCl, it is the same number of moles of lithium hydroxide. Now, what is he asking for? Concentration. Concentration is number of moles over volume. You have to remember the three equations that we talked about. Concentration is number of moles over volume, and the volume has to be divided by 1,000 before I put it into the equation. So this is my concentration of lithium hydroxide. Okay. Ethanol is made from sugars by fermentation. The mass of 1 mole of glucose is this. Calculate. So he gives me the MR of glucose, so I don't need to sit down and calculate the MR of glucose. It would be a waste of time. Calculate the maximum mass of ethanol, which could be obtained from 72 grams of glucose. Ignore the word maximum. For some reason, it confuses students. All he's asking is calculate the mass of ethanol that will be obtained from 72 grams of glucose. So I'm starting with 72 grams of glucose. What is the first thing that I should do? Number of moles. 72 over the molecular mass that he gives me is 0.4 mole. Now, the next thing is, what is he asking about? He's asking about ethanol. So I need to relate from the equation the number of moles. Now, the equation tells me that if I have 1 mole of glucose, it will give 2 moles of ethanol. And that means that the number of moles of ethanol should be twice the glucose. So the number of moles of ethanol is 0.8. Now he wants what? He wants mass. How do we get mass? Mass is the number of moles times the MR. So we calculate the MR of the ethanol, and the mass is the number of moles times the MR. So that comes out to be 36.8 grams. Okay, I hope you were able to get this answer. Okay, calculate the maximum mass of carbon dioxide given off. So I want mass of carbon dioxide. When 20 grams of small lumps of calcium carbonate react with 40 centimeter cubed of hydrochloric acid, concentration 2 mole per decimeter cube. So here actually he gives me information about calcium carbonate and information about the acid. So I need to get the number of moles of each one from the information. So number of moles of calcium carbonate is the mass over the molecular mass of calcium carbonate, so that's 0.2. The number of moles of HCl from the information that he gives me is 0.08 mole. And then I take a look at the equation. What does the equation tell me? The equation says that the number of moles of HCl should be twice that of calcium carbonate. Is it twice, or more than, or less than? The number of moles of calcium carbonate is 0.2. The number of moles of HCl is 0.08. So actually, it is much less. The number of moles of HCl is much less than what it should be. Because if I have 0.2 mole of calcium carbonate, I will need only 0.1 of HCl. I have less than 0.1, so that is the limiting reagent. So that is the one that I should use to calculate whatever he's asking for. So HCl is the limiting reagent. I calculate the number of moles of carbon dioxide relative to the HCl. I ignore the one for calcium carbonate. So the HCl is 0.08 mole. The carbon dioxide should be half of the HCl, so that is 0.04. The mass of the carbon dioxide will be number of moles times the MR, and that comes out to be 1.76 grams. Okay, so again, reminder, if he gives information about both reactants, you calculate number of moles of both from the information and then determine from the equation which of these is excess. Okay, sulfur dioxide can also be made by the reaction between a sulfite and an acid, and he gives you the equation. Excess hydrochloric acid was added to 3.15 gram of sodium sulfite. Calculate the maximum volume measured at room temperature of sulfur dioxide which could be formed, and he gives me the mass of 1 mole. Remember, the mass of 1 mole again is the molecular mass, so he already calculated the molecular mass of Na2SO3 to be 126 grams. Molecular mass is in grams. Okay, so which information did he give me? He says 3.15 gram of sodium sulfite. And he gives me the information, mass of molecular mass. So the first thing I should do is get the number of moles of the sodium sulfite. Mass over molecular mass, that comes out to be 0.025 mole. Then, what is he asking about? He's asking about sulfur dioxide, the SO2. Now, I look at the equation. What is the number of moles of the SO2 relative to the Na2SO3? The sodium sulfite from the equation has the same number of moles as the SO2. So SO2 would be the same 0.025 mole. Now, what is he asking again? Calculate the volume of sulfur dioxide. So how do I get volume of a gas? Remember that this is volume of a gas. So volume of a gas is number of moles times 24, and that comes out to be 0.6 decimeter cubed. In another experiment, it was shown that 15 centimeter cubed of the acid neutralized 20 centimeter cubed of aqueous sodium hydroxide, 1 mole per decimeter cubed. So he's giving me information about sodium hydroxide, volume and concentration. And he's saying he wants the concentration of the acid. So first of all, I need to get number of moles of whatever he gives me information for. So number of moles of sodium hydroxide, do not forget to divide the 20 by 1000, so I get 0.02 mole. Then, what should I do? He's asking about the acid. I look at the equation and relate it. What would be the number of moles of the acid? Well, the equation says it is the same as sodium hydroxide. So, number of moles of hydroiodic acid, this is hydroiodic acid, to give 0.02 mole. Now, he's asking for concentration. How do we get concentration? Concentration is number of moles over volume. So, the number of moles that we got over the 15 centimeter cube divided by 1000 before I put it into the equation. So I end up with this concentration. Okay. In an experiment, a 60 centimeter cubed of a sample of biogas, so biogas is some sort of gas, he will tell me what it is, required 80 centimeter cubed of oxygen for the complete combustion of the methane in the sample. Calculate the percentage of methane in the biogas. Assume that biogas contains only methane and carbon dioxide. So, biogas is a mixture of two gases, methane and carbon dioxide. Now, we're burning 60 centimeter cubed of this mixture, and it required 80 centimeter cubed of oxygen. Of course, only the methane will burn. The carbon dioxide will not burn. So I can relate the volumes of gases. These are volumes of gases. He's saying 80 centimeter cubed of oxygen. So if I have 80 centimeter cubed of oxygen, this should react with how much from the equation? The equation says that the volume of the gas, of the oxygen gas, should be twice the volume of methane. So it reacts with 40 centimeter cubed of. So that means that out of the 60 centimeter cubed of biogas, you have only 40 centimeter cubed of methane. Methane would be 40 over the total times 100. So that would be this percentage. Okay, 20 centimeter cubed of aqueous silver nitrate, concentration this, was mixed with 20 centimeter cubed of aqueous potassium chromate, concentration this. After stirring, the mixture was filtered. The precipitate was washed several times with distilled water. The precipitate was then left in a warm oven for several hours. And the first question says, what mass of silver nitrate is needed to prepare 100 centimeter cubed of silver nitrate, concentration this? So if I have 100 centimeter cubed of silver nitrate with this concentration, what would be the mass? In order to get mass, I need to get number of moles. So get the number of moles first of this solution. Number of moles is concentration times volume. Concentration is 0.2 and the volume divided by 1000 is 0.1, and that means I have 0.02 mole. Now he wants mass. How do I get mass? Mass is number of moles times the MR, and he already gives me the MR, so I don't need to waste time and calculate it, and that means the mass I need is 3.4 grams. Okay, what is the maximum mass of silver chromate which could be obtained from 20 centimeter cubed of aqueous silver nitrate, concentration this? Okay, what is the number of moles of silver nitrate? How do I get number of moles of silver nitrate? I have concentration and volume, so I'm going to use concentration times the volume, so that comes out to be 0.004 mole. What would be the number of moles of silver chromate formed? Well, I look at the equation. Where is the equation? We're talking about silver nitrate and silver chromate. Now, the silver nitrate and silver chromate from the equation shows that the number of moles of silver nitrate should be twice that of silver chromate. So, if I want the silver chromate should be half of that. Okay? So, if the silver nitrate is 0.004, my silver chromate is 0.002. Now, he already gives me the mass of 1 mole, which is the MR of silver chromate, and he wants the mass. How do I get mass? Mass is number of moles times MR, and that comes out to be 0.664 grams. This question says 20 centimeter cube of a hydrocarbon was burnt in 175 centimeter cube of oxygen. After cooling, the volume of the remaining gases was 125 centimeter cube. Addition of aqueous sodium hydroxide removed carbon dioxide, leaving 25 centimeter cubed of unreacted oxygen. Okay, what is happening here? First of all, he has a hydrocarbon, and we know that a hydrocarbon is made up of carbon and hydrogen, and he burnt it in oxygen. Now, remember from previous knowledge of organic, or when we do organic we'll talk about it, that when I have a hydrocarbon and it reacts with oxygen, it forms carbon dioxide and water. And the idea here is I don't know what the hydrocarbon is, so I don't know the C is how much and the H is how much in the hydrocarbon, and that's what we're trying to get. And he's saying he started with 20 centimeter cubed of a hydrocarbon and burnt it in 175 centimeter cubed, and at the end 25 centimeter cubed of unreacted oxygen remained. So that means that he put 175 centimeter cubed of oxygen, but that was excess because some of it remained. He started with 20 centimeter cubed of a hydrocarbon, and the point is we're trying to find out the balanced equation so that I can know what is X and what is Y. Okay, he says after cooling, the volume of remaining gases was 125. Remember that when you cool, water is no longer a gas, so water is not included. So the remaining gases would be the carbon dioxide that was formed and the rest of the oxygen that is unreacted. So he says the carbon dioxide formed and the rest of the oxygen that is unreacted is 125. The addition of sodium hydroxide removed the carbon dioxide from this 125 and left 25 centimeter cubed of unreacted oxygen. So if I'm left with 25 centimeter cubed of unreacted oxygen, how much actually reacted? I put 175, 25 remained, so I used up 150, so the volume of oxygen used was 150 centimeter cubed. Now, he says the remaining gases were all 125, and we already said that the 125 is the carbon dioxide plus the unreacted oxygen. So if the unreacted oxygen is 25, then the carbon dioxide was what? Was 100. So that means that the volume of carbon dioxide formed was 100 centimeter cubed, and I have ratios between the volumes of the reactants and the product. So if I say 20 centimeter cubed of the hydrocarbon reacted with 150 of the oxygen to give 100 of the CO2, well, I can simplify all this by dividing by 20 in order to have some sort of balanced equation. So if I divide all through by 20, the CXHY will have 1 in front of it. The oxygen will have 7.5. We're dividing the 150 by 20, so that's 7.5. And that should give me 5 in front of the CO2. Now, if I put 7.5 in front of the oxygen, that means I have how many oxygens before the arrow? I have 15. And that means I need 15 oxygens after the arrow. I already have 2 times 5 is 10 in the CO2, so I need 5 in front of the water to give it 15 oxygens on both sides of the arrow. So if I put 5 in front of the CO2, that also means that the carbon in the hydrocarbon has a 5 at the bottom, so that I have 5 carbons before the arrow and 5 carbons after the arrow. Now, how many hydrogens do I now have after the arrow? I have 10 after the arrow. That means that the H has 10 under it, so that means that my hydrocarbon is C5H10. Do we understand how we got that? You try to use the volumes of gases to produce the ratios between the number of moles in the equation, and thus you get a balanced equation. Okay, the next question says basic lead carbonate has this formula. X and Y are whole numbers, and he says it is a compound that is made up of 2 things, lead carbonate and lead hydroxide. If the lead carbonate is heated alone, it will give lead oxide and carbon dioxide. If the lead hydroxide is heated alone, it gives lead oxide and water. And from the equations, the number of moles of carbon dioxide is the same as the number of moles of lead carbonate, which is the X in the compound. And the number of moles of water is the same as the number of moles of lead hydroxide, which is Y in the original compound. So when heated, he found that this compound made of lead carbonate and lead hydroxide gave 2.112 grams of carbon dioxide and 0.432 grams of water. So if I can get the number of moles of each of these, then I would know the number of moles of the lead carbonate and the lead hydroxide, and as such I can get what is X and what is Y. Okay, so what is the number of moles of carbon dioxide formed? We have 2.112 grams, so I'm going to say number of moles is mass over molecular mass. So the mass over the molecular mass of carbon dioxide is 0.048 mole. What is the number of moles of water? The mass of the water, 0.432, over the molecular mass. And by the way, he gives me the molecular mass of each of them, so don't sit down and try and calculate it and waste time. So number of moles of water is 0.024 mole. Now, in order to get X and Y, we said the number of moles of the CO2 is the same as that of lead carbonate, which is X. The number of moles of water is the same as that of Y, which is lead hydroxide. But I need to simplify these numbers in order to get X and Y. And we said when we have 2 ratios and we're trying to simplify them, we divide by the smallest. So obviously in these 2 numbers, the smallest is the 0.024. So I divide all through by the 0.024 and I get a ratio of 2 to 1. That means that the X is 2 and the Y is 1, and that means that the formula now is this. Of course, we do not write a 1 in front of anything, it's understood. Okay, now another one, strontium chloride 6 water can be made from the insoluble compound strontium carbonate by the following reaction, and he gives me the reactions. In the above experiment, 5 centimeter cubed of hydrochloric acid of concentration this was used, and 6.4 grams were made. Now remember, he's saying he did the experiment and at the end he got 6.4 grams. I'm not going to use that 6.4 grams for anything for now, because this is the actual yield that he got. I need to calculate the theoretical yield that he should get. So let's go through the calculation. Number of moles of HCl used. What does he tell me about HCl? 50 centimeter cubed of HCl, concentration 2 mole per decimeter cubed. So the number of moles, this is a solution, is concentration times volume, 2 times, and remember this volume 50, you have to divide by 1000 before you put it into the equation. So I have 0.1 mole of HCl. So what would be the number of moles of the strontium chloride? Well, I look at the equation. 2 HCl gives 1 strontium chloride. That means that the number of moles of strontium chloride is half that of HCl. So 0.1 divided by 2, that is 0.05. Now he's saying mass of 1 mole of this is 267, so that is the MR. Now get the theoretical yield. Again, I'm going to remind you the word yield means mass. So we're trying to get the mass of strontium chloride that he should get. How do we get mass? Mass is number of moles times the MR. So we find that he was supposed to get 13.35 grams. But what did he actually get? He got 6.4, then the percent yield is 6.4 over the 13.35 times 100, and that comes out to be about 47.9 or 48% yield. Okay, 20 centimeter cubed of sulfuric acid with this concentration was added to 40 centimeter cubed of sodium hydroxide with this concentration. Again, he's giving me information about the acid and information about the base. So I need to use that information to calculate number of moles of each of them and then determine which one is excess. Again, when he gives information about both reactants, you have to determine which one is excess and which one is limiting first. Okay, how many moles of sulfuric acid were added? What do we know about sulfuric acid? Concentration and volume. So it is concentration times volume, and that comes out to be 6 times 10 to the minus 3 mole. You can leave it like this, or you can write 0.006. It's the same. How many moles of sodium hydroxide were used? Well, he said I have 0.2 concentration times the volume, remember, divided by 1,000. So this is 8 times 10 to the minus 3 mole. Now I look at the equation. What is the number of moles of sodium hydroxide compared to the sulfuric acid? The equation says that this number of moles of sodium hydroxide should be twice the sulfuric acid. Now, is the sodium hydroxide twice the sulfuric acid or less or more? Obviously, it is less. So the one that is in excess is the sulfuric acid. Do we understand that? So sulfuric acid is the one in excess because if the sulfuric acid is 6, then the sodium hydroxide should have been more than that. So what we have in sodium hydroxide is less. So sodium hydroxide is the limiting reagent and sulfuric acid is the excess reagent. Okay, based on this, would the pH, the final pH of the mixture, less than 7, equal to 7, or more than 7? We've already done acids and bases, and you should know if I have a solution that has excess sulfuric acid, that means the solution is acidic, and that means its pH will be less than 7. Okay? In this reaction, barium chloride plus magnesium sulfate to give barium sulfate plus magnesium chloride. This reaction can be used to find the X in the formula of the hydrated magnesium sulfate. So magnesium sulfate X water. So we're trying to get what is X. A known mass of hydrated magnesium sulfate was dissolved in water. Excess barium chloride was added. The precipitate of barium sulfate was filtered, washed, and dried. Finally, it was weighed. Now, mass of hydrated magnesium sulfate was 1.476 grams. The mass of barium sulfate formed is 1.398. So the idea is I have information about the barium sulfate formed. I can get the number of moles of barium sulfate. Based on that, I can determine the number of moles of the magnesium sulfate. And from that, I can calculate the molecular mass of magnesium sulfate X water. Do you understand what we're doing? We're trying to get the molecular mass of magnesium sulfate X water. Since I don't know what is X, I cannot sit down and calculate magnesium sulfate X water is what molecular mass. So we're going to do it this way. So first of all, I have information about barium sulfate, and he's saying calculate the number of moles of barium sulfate formed. How do I get number of moles of barium sulfate? Number of moles is mass over molecular mass. So that comes out to be 6 times 10 to the minus 3. And notice he gives you the mass of 1 mole or the molecular mass of barium sulfate so that you don't need to sit down and calculate it. Okay, number of moles of magnesium sulfate X water from the equation on top. The number of moles of barium sulfate is the same as number of moles of magnesium sulfate. So that would be the same. Now, the mass of 1 mole of magnesium sulfate, MR. Usually the MR of something I can sit down and add the masses of each one, but because I don't know what is X, I cannot do that from the periodic table. So I have to do it from the other equation that says number of moles is mass over molecular mass. I want molecular mass. So how do I get molecular mass? Molecular mass will be the mass over the number of moles. The mass is given on top. The mass of hydrated magnesium sulfate is 1.476. And the number of moles I have already calculated. 6 times 10 to the minus 3 or 0.006. That gives me a molecular mass of 246. So now I know that the total molecular mass of the magnesium sulfate X water is 246. Now looking at the MgSO4 alone, the molecular mass of MgSO4 alone is 120. And the total is 246. So can I get the mass of the X water? If the total, all of them, is 246, and the MgSO4 alone is 120, then the X water is the difference between them. So the X water is 126. So that means X times the molecular mass of water is 126. That means 18, the molecular mass of water is 18. 18X is 126, and I need to solve for X. So X will be 126 divided by 18, and that is 7. And that means the formula is MgSO4 7H2. Okay, there are 3 possible equations for the thermal decomposition of sodium hydrogen carbonate. So he gives me an equation which he calls equation 1, equation 2, equation 3. The following experiment was carried out to determine which one of the above is the correct equation. We don't know which one is the correct one, so we're going to do an experiment. A known mass of sodium hydrogen carbonate was heated for 10 minutes. It was then allowed to cool and weighed. The mass of the original sodium hydrogen carbonate was 3.36. The mass of the residue, the solid that formed after I heated it, is 2.12. Now the question is, I don't know whether this solid is Na2O, if it is following equation 1, or NaOH, if it is following equation 2, or Na2CO3, if it is following equation 3. And we try to determine which equation it is. Okay, he's given me already molecular mass of everything, so I don't need to sit down and calculate molecular mass of anything. So, first thing he wants, number of moles of sodium hydrogen carbonate. We know the mass of sodium hydrogen carbonate, 3.36. I want the number of moles, so the number of moles is the mass over the molecular mass that he gives me, and that is 0.04 mole. So that's the number of moles of sodium hydrogen carbonate. Now, if the residue is sodium hydroxide, remember, I'm going back again, the residue, he says, I have a mass of 2.12. Okay, 2.12 grams is my residue. So from this mass, I can calculate the number of moles if it is Na2O, the number of moles if it is NaOH, and the number of moles if it is Na2CO3. So in each case, the mass over the molecular mass of that substance will give me a certain number of moles. Now, use the number of moles calculated to decide which one of the 3 equations is correct. Now, I'm going to go back again to the 3 equations. The 3 equations, one of them says that the number of moles, equation 1, the number of moles of the residue should be half the number of moles of what I started with. If it's equation 2, then the number of moles in A should be the same as the number of moles in sodium hydrogen carbonate. In equation 3, the number of moles of the residue should be half the number of moles that I started with. So in that case, we're trying to choose which one. Now, he said I had 0.04 mole, and the number of moles of sodium carbonate was 0.02. So that means that the equation 3 is the correct one, since the number of moles of the residue is half of that of sodium hydrogen carbonate. Okay? Okay. 6 grams of cobalt carbonate was added to 40 centimeter cubed of hydrochloric acid, concentration 2. Calculate the yield of cobalt chloride 6 water and show that the cobalt carbonate was in excess. The first thing he's asking for is number of moles of HCl. So what did he tell me about HCl? He said 40 centimeter cubed of HCl with concentration of 2 mole per decimeter cubed. So the number of moles for a solution of HCl is concentration times volume, and that is 0.08. Okay, number of moles of cobalt chloride formed. Now the number of moles of cobalt chloride formed, where am I going to get it? From the relationship in the equation. The equation says 2HCl will give 1 cobalt chloride. That means that the number of moles of cobalt chloride is half that of HCl, which would be 0.04. Now, the number of moles of cobalt chloride 6 water, the equation says that 1 cobalt chloride will give 1 cobalt chloride 6 water. So that means that the number of moles of cobalt chloride 6 water is still the same as that of cobalt chloride. Now, if the mass of 1 mole is 238, what would be the mass of cobalt chloride 6 water? The mass will be number of moles times mR, which is 9.52 grams. Okay, to show that cobalt carbonate is in excess, he's saying, first of all, number of moles of HCl used. We already calculated the number of moles of HCl used at the beginning. It was 0.08. And he's telling me the mass of 1 mole of cobalt carbonate is 119. So what would be the number of moles of cobalt carbonate? The cobalt carbonate, he says it's 6 grams. So 6 over the molecular mass is 0.05. Now, comparing the 0.08 and the 0.05, the HCl is 0.08 and the cobalt carbonate is 0.05. If I look at the original equation, it says the number of moles of HCl should be twice the number of moles of cobalt carbonate, or the number of moles of cobalt carbonate should be half the number of moles of HCl. So if I have 0.08 of HCl, how much should I need for cobalt carbonate? It should be half of the 0.08, so actually I need only 0.04, but what he put was 0.05, so that is why cobalt carbonate is excess, because 0.08 mole of HCl will need to react with only 0.04 mole of cobalt carbonate, which is less than 0.05. Okay, barium carbonate decomposes when heated, and he gives me the equation. The student heated a 10-gram sample of barium carbonate. So what would be the number of moles of barium carbonate? From 10 grams, number of moles is mass over molecular mass, and that comes out to be 0.05 mole. Okay, calculate the volume of carbon dioxide produced at room temperature. Now, if the number of moles of barium carbonate is 0.05, from the equation on top, what would be the number of moles of carbon dioxide? It will be the same. So, getting the volume is number of moles times 24, and that is 1.2 decimeter cubed. Okay, the student added 2 grams of barium oxide produced to water. Calculate the mass of barium hydroxide that can be made from 2 grams of barium oxide. So I need to get the number of moles of the barium oxide first, and from the equation, the number of moles of the barium oxide is the same as the number of moles of barium hydroxide. So how do I get mass of barium hydroxide? Number of moles times mR, and he already gives me the mR, so my total mass would be 2.22. Following? Getting easier? Okay. 1.5 grams sample of barium hydroxide dissolved in water. The total volume of the solution was 100 centimeter cubed. Then he took 25 centimeter cubed of this solution and titrated it against hydrochloric acid. So the 25 centimeter cube portion that he took was actually something that had 1.5 grams in 100 centimeter cube. The volume of hydrochloric acid required in the titration was 18.75 centimeter cube. So calculate how many moles of barium hydroxide were in the 25 centimeter cube portion used in the titration. Now, you have 1.5 grams in 100, so you can get the number of moles in 100, and then you determine the number of moles that would be in the 25. So the total number of moles is the mass over molecular mass, the 1.5 over the molecular mass, 171, and that is the number of moles. But this is the number of moles that is in 100 centimeter cubed. He took 25 centimeter cubed out of that, so that it means that now the number of moles is a quarter of what it was originally, so 2.19 times 10 to the minus 3. Okay? Then concentration. I now have the number of moles, the concentration, number of moles of HCl. We're talking here about calculate the concentration of hydrochloric acid. Hydrochloric acid, what did he say about hydrochloric acid? He said I have 18.75 centimeter cubed of hydrochloric acid. So we have number of moles of the hydrochloric acid. Remember that the equation says if I have 2.19 times 10 to the minus 3 mole of barium hydroxide, from the equation the number of moles of HCl should be twice. So the number of moles is twice, that is the number of moles of HCl. From that I can get concentration. Concentration is number of moles over volume, the number of moles that we calculated over the 18.75 in decimeter cubed. So this is the concentration of hydrochloric acid. Okay, a student studies the rate of decomposition of hydrogen peroxide. The student uses this amount and 1 gram of manganese oxide. And he gives you the equation. Calculate the number of moles of hydrogen peroxide. What does he say about hydrogen peroxide? 20 centimeter cubed of 0.1 mole per decimeter cube. That's the solution. So number of moles is concentration times volume. Again, remember to divide the volume by 1000. So that gives me 2 times 10 to the minus 3 mole. Now use your answer and the equation to calculate number of moles of oxygen. Now if this is the equation and I have a certain number of moles of H2O2, what would be the number of moles of oxygen? The equation says 2 will give 1. So the number of moles of oxygen should be half of what we got for the hydrogen peroxide. So this is the number of moles of oxygen. Now calculate the volume of oxygen. How do I get volume? Volume is number of moles times 24. So it is 0.024 decimeter cubed. Okay, calculate the volume of chlorine gas at room temperature and pressure that reacts completely with 400 grams of TiO2. The first question says calculate the relative formula mass of TiO2. That is the molecular mass. And we said molecular mass, you just add up all the masses. So titanium has a mass of 48, and remember this is titanium, so don't look at tellurium, for example. This is titanium, 48, plus 2 times 16, which is 80, so the molecular mass is 80. Now, number of moles in the 400 grams of that will be number of moles is mass over molecular mass, so that gives 5 moles. What would be the number of moles of chlorine that will react with it? I look at the equation, and I find that number of moles of chlorine is twice that of titanium dioxide, so that means I have 10 moles of chlorine. That means that the volume of chlorine that reacts with this amount is number of moles times 24, which is 240. Okay, so we're done. It was a long one this time, but good, we've done it, and I hope that you understand everything and study everything so that you can be ready for a